Hello everybody! Hello, today we're on Chapter 8, and Chapter 8 deals with chemical reactions and thermochemistry, also known as thermodynamics. And this is really the meat of why reactions happen. As we've talked about before, reactions for the most part happen because atoms want to get to the lowest possible energy state. Remember that. And so thermochemistry describes how that happens. So if we keep track of some energy differences and changes as reactions happen, we can predict whether they will happen or not from a thermochemical standpoint. Okay, so the main question once again, how can we predict when reactions happen? How do we know if they happen or not? And what makes them happen? There we go again, the big general urge to get to the lowest possible energy level. Okay, you can think of this as my college teacher used to say, you can think of this as atoms are very lazy. They will not want to be at a high energy state, so they want to get to the lowest energy state. And if we keep track of the energy changes, we can predict which reactions will take place. So first, let's talk about the 4 general categories of reactions. Barron's book goes through all of these and explains how you can predict whether each one will happen. So this is kind of the 4 major categories of reactions that we will encounter. First, we have combination, also known as synthesis. Then we have decomposition, also known as analysis. Single replacement or single displacement, the same thing, and double replacement, or like I like to say, double displacement. Okay, let's look at each one separately. So first, number 1, combination or synthesis reactions. These reactions are just like what they sound like. It is when elements come together to form some kind of a compound. It is the synthesis, the making of something, okay? So for example, here we have zinc combining with sulfur to give us zinc sulfide. Okay, here we have hydrogen gas combining with oxygen gas to give us our very favorite water. And here we have carbon combining with oxygen gas to give us carbon dioxide. So synthesis is when you're making something. So remember that combination reactions are just like that. Then we have decomposition. What do you think that means? It's the opposite of synthesis, right? It's breaking things apart. So first we start out with some kind of a molecule, some kind of a compound like water, and then we break it apart. And do you remember from the previous lesson, what is the oxygen extraction method or the hydrogen gas extraction method from water? It's through electrolysis, right? When we put a large current in water, a lot of electricity, and then we have these gases come apart.